Leah Lin. She is going to talk about revisiting the mysterious origin of FRB with machine learning classification. This is another talk about machine learning classification of FRBs. Her talk is contributed, therefore her talk includes 12 minutes for talk and then 3 minutes for Q&A. Leah, please start when you get ready.
Okay, hello everyone. I'm Leah from National Tsinghua University. I'm the graduate student, and here's my advisors and collaborator. Well, today I'm going to present my recent work, revisiting the Mysterious Origin of FRB 12.11.02a with machine learning classification. Here's my outline. And before introducing my work, I'm going to talk about the mystery of origin of FRB, and so that I will present my results and also comparing the two previous work. And here's the mystery of origin FRB. FRB is the extremely high energy and millisecond time scale radio wave, and the origin remains unknown. Here's some candidate origin, like white dwarf, neutron star binary, or stellar mass black hole. Above these, those are the older origin. As for the younger origin, there are such as magnetar, young pulsar, supermassive black hole, and supernova. But there's not only them, but also something unknown. Maybe there are something can also generate FRB, but we don't know. And here's my abstract of my working. To reveal the mysterious origin of FRB, we are trying to use machine learning classification to find the physical mechanism of this FRB origin. And why we have chosen using machine learning? That's because we are attempt to find the different physical mechanism of this origin. But why we use machine learning rather than by hand? Because for us human, it is difficult to handle many parameters at the same time. So machine learning can help us to do that. And let me introduce what is UMAP. UMAP is one of the machine learning equipment. And how it works. For example, here's a elephant which is composed with higher dimension data points. And after UMAP work on this elephant, those data points project into lower dimension data point, so that we can analyze this data easier. So this is why we use UMAP. And here's my data that here's the data that we have chosen. The data is from the telescope, radio telescope Arecibo, and which include more than 800 FRB. Exactly is 879. And why we choose the Arecibo? This is a wide range of observation frequency between 4 to 8 gigahertz, and the observation time from 2018 26 August to 2019 21 February. And as for the diameter is really large, about 304.8. It is such a large telescope. The more larger telescope is, the more sensitivity it has. As for the period of the FRB origin, it's about 160 days. And the next step of my work, fit the data into the put into the machine learning and do the classification, including those 10 parameters in time of arrival, amplitude, linear temporal drift, arrival time, time duration, central frequency, bandwidth, scale energy, fluence, and dispersion measure. And comparing to the previous work, and here's mine, and comparing to Jasper's work, there are many parameters we have choose same, but I'm more than he has chosen. As for Oliver's, the parameter he has chosen is far different from us, and also he chose the more parameters. As for the observation telescope, I have chosen irreversible, and as for Oliver, he has chosen chime. As for Jasper, he has chosen fast. And the advantage of the irreversible, it can observe the wider range of frequency. Also, it can observe the longer time. But there's pros. Also, there is cons, because we cannot obtain the new data anymore from irreversible, since it is the telescope which is passed away. And let me show my results. Well, as we can see on the left of this page, machine learning classified those FRB data points into 4 different groups, and it may indicate the origin generate the 879 times FRB with 4 different physical mechanisms. As for some people may ask me, are there any physical meaning on x-axis and y-axis? My answer is no. Let me explain why. In the origin, here is a higher dimension data point, and the parameters have different weighting on these data points. But after projecting, those weighting are gone. So this is why there are no any physical meaning on the x-axis and y-axis. And go to the and here's the comparison to the previous work. As we can see, all of us use the same machine learning UMAC, but here is some looks different. The result looks different. That's because besides we use different parameters, Also, the parameters in Python, we have different parameters in the Python code, so it looks different. Also, our proposed are not same. As for Oliver, he is trying to find the repeating and non-repeating FRB. Oh, I see.
2 minutes left.
Thanks. As for me, I'm trying to find the physical mechanism, a different physical mechanism of this arranging. So to Jasper, I forgot. And so in order to know what the classification basis, we have made those histogram of the parameters to each cluster of those FRB. As we can see, those parameters looks distribute uniformly, but arrival time. Is there any meaning of the different arrival time? We are still searching. As we can see, the arrival time is far different. So the arrival time is the arrival time dominating this classification. And here's my summary. First, the origin generate the 879 times FRB with 4 different physical mechanisms. And the my next goal is find what the 4 physical mechanisms. And the last but not least, is it possible to find the exact origin? To be continued. That's all. Thanks for your listening.
Thank you very much. Do you have any questions from on-site people first? Yes, Albina, please.
Thanks, Leah, for the interesting talk. Perhaps this is also a question related to Jasper's and Oliver's talk. So if I understand correctly, you use UMAP to look at 3 different data sets between the 3 of you, from Chime, from FAST, etc. So I'm wondering if you've ever tried using different machine learning methods to look at one data set. Do you still get similar clustering results, or do they look different? If they look different, then what can we say about the machine learning method that you've chosen to look at possible physical implications to your results? I'm just wondering. Thank you.
Good question. Honestly, I haven't used any other classification, any other machine learning to do the classification. So I don't know whether there are same results if use the different machine learning.
Can I add a little bit on this question? In our cases, me, Jasper, and Leah, because UMAP always work good enough for our cases, so we haven't tried any other algorithm. But in another paper has done this. It actually did almost same things on the Chime catalog. Actually the identical data, and trying to solve the hidden repeater stuffs. And they have tried another clustering algorithm, called TNSD, and actually the results was quite similar with UMAP. So we can say that actually changing the algorithm might not fundamentally destroy all the results we got. Okay, so is it quite similar?
Thank you.
Thank you, Oliver.
Okay, so thank you very much. It's time to move on the next talk. So let's thank the speaker again. And we still have a question from all of the students.